This is a walkthrough through your homework 11, which is SPSS based. So hopefully you've been able to find SPSS at the library. And I'm going to post this for you so it'll help you walk through the data. Now, I provided you with this worksheet that has some data provided for you. It also has a little bit of a synopsis of some research that was performed comparing a no treatment, placebo, Cerezac, an Effexor, and a cheer up session to each other to see if one of these alleviates more depressive symptoms as measured by the Hamilton scale. Now, right here is the SPSS code for treatment, which will become important later. And also you'll see I've given you an abbreviated data set. Now these data sets, this data set right here, is not the full data set that you've worked with previously. It only has half the participants, which means it's not going to have as much power to detect significant differences. Now, the first question that I ask on this homework is what kind of null hypothesis significance test is appropriate for this data? Now, an independent sample t-test is not appropriate because it has more than 2 levels. Okay, it has 5 different treatment conditions. So the most appropriate test would be a one-way ANOVA. Okay, one-way analysis of variance. Okay, so you can simply put it in there. Now the next thing that you need to do is you need to be able to put this data into SPSS. Okay, and so what you're going to need to do, okay, is I've entered it already for you. You're going to need to enter in your treatment conditions into column A. So you can see this is 0 coincides to no treatment, 1 coincides to placebo, Cerezac coincides to 2, Effexor coincides to 3, and cheer up session coincides to 4. And you can see this coding right here in the SPSS code for treatment. Now you see this data, you'll notice that all the no treatment data is associated with all the 0 data, all the placebo data is associated with the 1 data, as you can see in the SPSS window right here. Now once you've entered in the data and you have 2 columns, the next thing you want to do is you want to go to variable view. Now you click on here, and what I've done is I just typed in treatment IV, and then I clicked here and I've clicked difference DV. Now I've put an underscore here to kind of space out IV and DV. I think SPSS now includes spaces, but it didn't used to. It had trouble with spaces. Now, once you get these names, okay, the variables named, you're going to go over to treatment IV, and you're going to see this value, okay? You're going to click on it, and it's going to have this little button that appears. You click the button, and what you do is you hit 0, type in no treatment, and hit add over and over again. And you can see here, okay, that I've already done it, but ultimately I'm naming all the variables for you, okay? So you're naming it so when it comes in the output screen, it'll make a little bit more sense. And you click OK, okay? And the next step, that once you've named all of your levels of your variable, you then go into Analyze up here at the top, and you go into Compare Means, you go into one-way ANOVA. Now once you get to one-way ANOVA, you'll notice that you'll put differences into your dependent list, because it's your dependent variable, and you'll put treatments, okay, into the factor list. Now you're also going to click on Options right here, okay, and you're going to click on Descriptive Statistics, which just makes sure that it provides you with means, it provides you with standard deviation, things to describe the data that you are analyzing. And then you're going to go down. Once you click Descriptive, you're going to click Continue. And then also I want you to click Post Hocs. Okay, go to Post Hoc. This is all the different types of post hocs that you can perform. You're not going to perform any of those that you don't know, so I just want you simply to click on the Tukis and click on Continue, and you click on OK after that. And you'll see now you have your data. Okay, you can see here you have the different treatment conditions, you have the sample size, you have their means, standard deviation, standard error. Now also you'll see you have the ANOVA. You can have the sum of squared, between, within, and total in the proper order. Degrees of freedom is 4, 20, and 24. Mean squared, and mean squared between, mean squared within, and then also you'll see an F of 2.362. Now you'll see that you have a significance value of 0.08, which is larger than 0.05. Okay? Because it's larger than 0.05, you need to go to homework 11 and you need to say, is there a significant difference between these conditions? And you should say no. Okay? There is no significant difference between these conditions. Now, this is where I want to introduce you. Now, you remember previously when you had 10 data sets, it was significant, but with only 5, you didn't have enough power to detect the differences that existed. So you're going to say no, but there's a term that I want to introduce you to, and that is called marginal. Marginal differences. So you have marginal differences, and marginal differences, pretty much it just says that you almost found something. Okay, so you have a 0.088, which is almost a 0.05. Okay, so we're going to assume that the marginal differences are something of worth, and therefore, by saying it's marginal, it gives us a permission to look at the post hoc analysis. Okay, so because we have permission, because we decided that it has marginal significance, I'm going to go to my output window, output, and you're going to see here, I'm going to look at my post hoc analysis, and I'm going to want to know what's causing my marginal effect. And you can see here you have treatment, okay, and this is no treatment. You can see here there's not a significant value here, not a significant value here, not a significant value here, and there is 0.07, which is larger than 0.05, but it's marginal. And because now we're deciding that marginal is interesting, we can then use it sometimes as long as we explain to people that it's a marginal effect. So you can see that part of the marginal effect in the ANOVA was probably due to the no treatment versus the cheer up session. And you can see that is probably, of all of the 5 groups, all of the comparisons between the 5 groups, we found a marginal effect. And that marginal effect was most likely due to the no treatment versus the cheer up session. So we get into your homework, okay? And you can see this is the instructions that I gave to enable you to look at things, okay? And based off the data above, what is the probability the differences are due to chance, okay? I would say they are low, okay, because they're 0.08. But there is still a higher level of chance than we like, okay? Because it's not lower than 0.05. We don't like that. What is your conclusion about the null hypothesis? It is possible that it is incorrect because of the marginal effect. Which treatments are significantly different from each other according to the Tukey's post hoc analysis? Now, in order to do this, which treatments are significantly different from each other, what I want you to be able to do is I want you to be able to, we looked at it, and what was different is the no treatment was marginally different from the cheer up. This suggests that the marginal effect that we observed was due to the difference between no treatment and cheer up condition. And why we would say this is because we can say this because none